Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to talk about how do we calculate pH using the auto-ionization of water. So what is the auto-ionization of water? It really comes down to how water interacts with another water molecule, either if you have a solution or with just pure water. Okay. Now, water can act like acids or bases, depending on the situation. So we're going to say that this first water is an acid molecule and the second one's kind of like a base molecule. And based on our previous learning in other videos, we know acids are things that donate protons. So we're going to basically move a hydrogen positive one ion over to the second water molecule. And remember, bases are things that accept protons. Now, we're going to put this reaction in equilibrium because it does work in the forward and reverse direction. So we're going to move the proton over here to this molecule, and when this water molecule receives that proton, it's going to make an H3O plus because we took the hydrogen positive one ion and we basically put it on a water molecule. So now it's H3O, and of course, because the hydrogen ion was charged, we get H3O plus. Now, when the H plus leaves this acid molecule, what's remaining is a hydroxide ion. And this is what we call the auto-ionization of water. Now, these are going to be aqueous solutions, and these things are pure liquids on the left-hand side. And what we're going to do with this ends up being incredibly important in chemistry. What we're going to do is we're going to calculate or write down the expression for the K value. Now, since this is water, we're going to call this Kw. Now, when we do the equilibrium expression, I want to remind you, we never include pure liquids or pure solids. So neither one of these water molecules are going to show up in our expression. And our expression for Kw becomes the products over the reactants, but since these are pure substances, they're not included. So really, it's just the products of hydronium ions and hydroxide ions. And this value is equal to a particular number that never changes because this is an equilibrium constant, which means the number doesn't change. And that's going to be equal to 1.0 times 10 to the negative 14. This number is going to be ingrained in your head because you're going to be using it all the time moving forward in chemistry. It's almost going to become like pi is in math class. Everybody knows that pi is 3.14. Everybody's going to know that Kw is equal to 1.0 times 10 to the negative 14. Now, what this does for us is that if you know the concentration of one of them, you're going to know the concentration of the other one because of this inverse relationship that exists between hydronium and hydroxide ions, okay? Because whenever you have two things that equals a constant, as one thing goes up, the other one goes down. And let me show you an example with numbers that aren't as complicated as 1.0 times 10 to the negative 14. Like, let's say I had this constant, okay, that's equal to 8, okay, and that's equal to A times B, okay? Well, if A is 1, then this is 8. If it was 2, then this is 4. If this is 4, then this is 2. And if this is 8, this is 1. What I want you to recognize, as one goes up, the other one is going down to equal the same constant number of 8. Well, that's no different over here, okay? It's just that the number is a little bit more complicated. It's 1.0 times 10 to the negative 14. But whenever you take two things and you multiply them together to equal a constant, just like I did over here, as one goes up, the other one is going to go down. So on our pH scale, okay, what I do know is at the very bottom of the pH scale is that there's lots of hydronium ions. And if there's lots of hydronium ions, if there's a high concentration of this guy, then there has to be very little of the hydroxide ions. So I'm going to put that down here too. Very little of the hydroxide ions. And of course, the opposite is true at the top of our pH scale. At the top of the pH scale, we have lots of hydroxide ions And if we have lots of hydroxide ions, if this is in large concentration, then this number is going to have to be very small. So we have very little hydronium ions. And what's really, really neat is what happens at pH 7. At pH 7, the hydronium ions are exactly equal to the hydroxide ions. Okay. Now, I keep calling this ion the hydronium ion, of which it is, but the hydronium ion can be thought of as the same thing as a proton. Okay, so hydronium and protons, they're basically, we're going to treat them exactly the same way. And just for reference, a proton is a hydrogen positive one ion. Because I really could have taken this water molecule and just done, this, just split it up into its ions and write down that Kw is equal to the protons times the hydroxide ions. Now, this is a little bit more accurate of what's really going on because this proton really is on top of a water molecule. So hydronium is a little bit more advanced chemistry than just calling these things protons. But when we deal with all our chemistry, as long as you treat protons like hydronium ions and hydronium ions like protons, you'll get to the same place. Okay, so this one's a little bit easier. So if I was teaching a regular chemistry class in high school, maybe I'd go this route. If I was doing an advanced class, like an AP class in high school, I would use this. Okay. Of course, if I'm in college, I'm definitely using kind of like the hydronium ion over the proton. Okay. Now, how are we using all of this? Okay. Well, we're going to use this information, and I'm going to give you the value of one thing, and then you're going to have to figure out the value of the other. Okay. And then we're eventually going to calculate the pH of a system. Okay. So let's say I come in and I say, hey, the hydronium ions are going to be equal to 3.5 times 10 to the negative 5. Okay. So if I have that value, then I can figure out the other thing. Okay. So if this value is 3.5 times 10 to the negative 5, and that's going to be multiplied by the hydroxide ions, which I'm going to try to leave in brackets to make sure we're talking about concentration. And that's always equal to 1.0 times 10 to the negative 14. Okay. Well, to solve for the hydroxide ions, I'm just going to divide both sides by 3.5 times 10 to the negative 5. Okay. And I find out that the concentration of my hydroxide ions, okay, are going to be 2.86 times 10 to the negative 10. Okay, that sounds great. Okay, so now that I have the concentration of both of them, I can find things called the pH or the pOH. Okay, so I'm going to come up here and erase this guy right here. pH is equal to the negative log of the concentration of either protons or hydronium ions. So I'm going to take this value of 3.5 times 10 to the negative 5 and plug that into the equation. So the negative log of 3.5 times 10 to the negative 5, I'm going to plug this into my calculator, negative log 3.5 times 10 to the negative 5, and I get a pH that's equal to 4.46. Okay? I'm going to do the same exact process, but instead of plugging in protons or hydronium ions, I'm going to plug in hydroxide ions. So if pH is the negative log of protons or hydronium ions, then pOH is going to be the negative log of the concentration of hydroxide ions. And I have that right here by using the Kw expression. Okay, so negative log of 2.86 times 10 to the negative 10, okay, if I plug this into my calculator, I'm going to get this answer of 9.54. Now, a great way of checking your work is by using the following equation, that pH plus pOH is always equal to 14. So I'm going to add these two numbers together in my calculator to see if it equals 14, just as a check to make sure I've done all my work correctly, okay? And when I do indeed get the value of 14, and therefore, I think I've done everything correctly in this problem. So at the end of the day, if we are given one of the following items, I want to write all these things on the board here, okay? If I'm given either hydronium or hydroxide or pH or POH, if I'm given one of those items, then I can calculate any of those items, okay? So in this problem, what I was given was the hydronium, and then I found the hydroxide, and then I found the pH, and then I used that to find the POH, and then I use this equation as a check to make sure that I've done everything correctly, okay? Now, what I want to do is another problem, okay, where I give you something else, okay, and then you have to figure out the other three. Now, one thing that I found students having a hard time doing is kind of working this backwards, okay? Like, they can always plug in the hydronium values to get the pH, but sometimes they have a hard time using the pH to come back and figure out the hydronium ion. So I just want to do a quick problem with that for you. I want to see, hey, can you get in your calculator and enter 4.46 some way to where you get 3.5 times 10 to the negative 5. Pause the video here, work on it for a few seconds, and then come back and I'll be working on that problem, okay? So if you've worked on that problem, you're going to find out that if I want to use the pH to figure out the hydronium ions, I have to use this equation. The concentration of the hydronium ion is going to be equal to base 10 to the negative pH. So in my calculator, I'm going to hit second log to get this base 10, and then I'm going to plug in negative 4.46 in order to get this concentration of 3.5 times 10 to the negative 5. And I think that's where we're going to start with the second problem in this video. Okay, so let me do some erasing, and we are going to work on the second problem where I give you one thing, okay, and it's not going to be the hydronium this time, it's going to be pH, okay? So from pH, you should be able to figure out everything else. So let's say I say the pH is equal to 2.25. Can you figure out these other three things from the value of 2.25? Okay, so I'm going to grab my calculator and we're going to work this problem out together. Remember, to figure out the hydronium ions, it's base 10 to the negative pH. Okay, so the first thing I'm going to do is go from pH to the hydronium ions. Okay, so if I wanted to figure out the hydronium ions, I'm going to take base 10 to the negative pH. So base 10 to the negative 2.25. And I'm going to plug that into my calculator. So I'm going to do second log to get the base 10, and then to the negative 2.25. And I get this answer of 5.62 times 10 to the negative 3. So I have the concentration of the hydronium ions. And if I have the concentration of the hydronium ions, then I can figure out the rest of the material that I need to figure out, okay? So remember, Kw is equal to the concentration of the hydronium ions times the hydroxide ions, and that's always equal to that number that's going to be ingrained in our head of 1.0 times 10 to the negative 14. I'm going to plug in the hydronium ions as 5.62 times 10 to the negative 3, and I'm going to use that value to figure out my hydroxide ions. The way I do that is by dividing that on both sides, 5.62 times 10 to the negative 3. And I'm going to pick up my calculator. And I'm going to do 1 times 10 to the negative 14 divided by 5.62 times 10 to the negative 3. okay? And I get my hydroxide ions to be 1.78 times 10 to the negative 12. Okay, so that's my hydroxide ions, 1.78 times 10 to the negative 12. And now I'm going to use this value to figure out the POH. Remember, POH is going to be the negative log of the concentration of the hydroxide ions, which is 1.78 times 10 to the negative 12, which is already in my calculator. So I'm just going to do negative log of that particular answer, and I get a POH that's equal to 11.75, okay? And then I'm going to do my check, okay? So if this is 11.75, I'm going to add these two numbers together, 11.75 plus 2.25. How about that? Okay, when I add those together, I get that answer of 14. So I always recommend you take pH and POH, add them together at the end just to make sure that I've done all this other math correctly. Okay. The next video, we're going to be figuring out these four things of strong acids and strong bases. If you found this content helpful, please give it a like and subscribe. And when you add that comment, it really does push the information out to other students that might be interested in learning chemistry.